Hello teachers and receiving students and HCs.
Hello, Mr. Chalani.
Thank you. You may sit down. We're still on the same strand. Science in the home, substrand using energy in the home, and our same outcome 8.3.3 apply their knowledge about energy to investigate electrical and heat in the home. In our last lesson we looked at energy. Can you remember, receiving students, how many types of energy do you know of? HC, can you remember the types of energy? Let's have Paul. Just one.
Kinetic, potential, and elastic.
Okay, thank you. Riku, any other types of energy that you know of?
Nuclear energy and heat energy.
Good. Some types of energy that which we looked at or which we did not look at are potential energy, stored energy, something that has energy but it is stored. So it is sometimes referred to as potential energy. Gravitational potential energy. This is when an object has energy in it, and when it is caused to fall or to move, this object moves. So example like waterfall, or if you drop a biro, this biro has gravitational potential energy. Next one is kinetic energy, moving energy, which we normally see or we normally carry out in our activities. Heat energy is the next one, and it has many sources. Sound, light, chemical energy, elastic potential energy, in which you did your elastic motor, and electrical energy, which is normally found in our homes. And the last one we do not have is nuclear energy, but in far western countries they do use nuclear energy. We all see vehicles, cars, trucks, buses, and we wonder how these things move or how they move. What form of energy do they use? So there are two questions that we ask when we look at these moving vehicles. What makes it move? And what type of energy powers the vehicle? Are there any other forms of energy when the vehicle is moving? Does it produce any other forms of energy? I'll give you a minute to discuss among your friends the two questions, and let's have some answers. Receiving students, there are two questions which you look at for a minute and discuss among your friends and come up with a few of your answers. A minute.
Is chemical energy, and the second question is potential energy. No, wait first.
Our discussion. First one is chemical.
Second one is potential.
What do you mean chemical and potential?
What makes the car move is the chemical.
Okay, I think we have come up with a few ideas, a few answers. Let's have Trisha to give one of the answers that the groups have come up with from the two questions?
We think that the first question is chemical energy, and the second one is potential energy.
Chemical energy, potential energy. The chemical energy powers vehicle to move, and there is also potential energy in the vehicle. Any others that you find in the other forms of energy that you find in the moving vehicle? Shane? Any other forms? We'll have Shane, the last one.
Sound energy, heat energy, and light energy.
Good. When the vehicle moves, powered by chemical energy, it makes sound. Huh? Do you hear sound from the vehicle? It produces sound energy. And it produces heat energy. When you touch the bonnet of the car, you feel the heat. So those are some of the energy. Our lesson topic is conservation of energy. We looked at conservation, the word conservation. What does conservation mean? Conservation. Violet. What do you think conservation is? The word conservation means?
Saving energy.
Saving energy. How do we save energy? Good. How do we save energy? Have 1 minute. How do you save energy? Do we save energy? How do we save energy? Tulanga. Can you tell us how we save energy?
By using it wisely.
Good answer. Yes.
By storing.
By storing. We'll collect some energy from the sun and we'll store it. How do we store it? Good question. Do we have energy in this battery? So it is stored energy. So this battery has stored energy. And stored energy is sometimes known as potential energy. This form of energy is a chemical form of energy. So it is a chemical potential energy. We will look at that in our activities. Conservation of energy is when energy we eat, we use up energy in the battery in our stereos or any other things that need battery. This energy is used. But how do we know that it goes out? It doesn't go. The energy is used. How do we know it goes? It is saved. 1 more minute. How do you know it is saved? How do we know it is saved? It is saved here, but when we put it in the radio, we play music, and there is sound energy and electrical energy traveling in the radio, in those wires, and produces sound energy. And then what happens? Battery becomes flat. Has the energy all gone out? Some energy. Some. What do you think? Helen.
Some batteries can be charged again, so maybe you charge it yourself, or like not play the radio for quite a while, and then like more energy stores up in it, and then you play it again, energy comes back.
Okay. Energy is energy. We cannot store energy. We can store it in this way, but when energy is used, it does not stay in one form. It does not stay in one form. It changes from one form to another form. You understand? So, looking at this battery again, we have chemical energy in here, but when you connect, it changes form, and from one form, it produces another form of energy. Okay. You receiving students and teachers, please take note of this table quickly. We are going to, in our activity, we will copy down a table and carry out some activities before we complete our worksheet. So this is what we will do in our activity A. Right, we should do the activity before we do our recording. So students who are out there, in this activity you must do the activity before you record. Do not record before you do the activity. Right, here is our table. If you can take note of the table quickly. Well, group leaders. Group leaders, come up to the front and get your worksheets. Any leftover papers, send them back, or give them to your friends who don't have one. And bring more. Okay, activity A there. Activity A, you will see activity A table. The first activity that we are doing is lifting a bucket of water from the floor onto the table. But we cannot do that because we might wet the table. So what we will do is there on the floor we have marked positions A to B. So you will carry the bucket of water from A to B and back again. If you don't have a bucket, there is a balloon of books I brought. So you can carry the balloon of bag, books, from point A to point B. I leave it here with, I leave it beside the table, and you can carry that out. So we have only 2 buckets. We have only 2 buckets. Please give chance to your friend. Do not rush. Do not push. We don't want to spill water. It will be hard work to clean up. So do not rush one at a time. One member of the group will carry out the activity, or you can have that 10 after the other. Let's begin our activity. Hey, begin. Your time is given to complete your first 2 activities on table A. Each of you have to try it because you have to feel it. If you don't try it, you will look at one Karim. He's doing it, but what about you? You must do it yourself. Carry and try it, so you know your answer. Good one. Did you complete the work for carrying the balloon from one point to another? So is work done? Have you used energy? Check your table. Right, our next activity is switching on a lamp in a circuit. So receiving students, that is our next activity. Runners, please come up and get your bulbs and material, dry cell, any. Let's begin. Peel the plastic off then. Okay. Yeah. Come. Check the bulb. Stick one side and you can connect the other. It's working? Is it? It's not working. Okay, try it out. Try it yourself. If it doesn't work, find out why it's not working.
Yeah, I'm supposed to exercise.
Well, you knew it and you should have tried it yourself.
Yeah, trying to
Disconnect it.
Ready.
Okay, try to fit it in there. Right? If you have finished activity number 2, those who haven't to carry on your activity 2, those who have finished activity 2, your next activity you will have a look at these pictures. 2 of the pictures. First one is moving vehicle and burning fires. So let's have a look at our picture 1. Picture 1. Do we have energy gained, lost? Where does this energy come from? Excellent. I see people discussing, which is good. When you discuss, you have a lot of ideas. Our second picture. Right, let's move on to our questions that we will look at these types of activities that we have done. Our questions that we look at, from the activity that we did, where did this energy come from and where has it gone? Where did your energy come from carrying the bucket from point A to point B, and that energy used, where has it gone now when you did the activity? Was there energy, or did you create energy before you carried the bucket? And can we destroy energy? Yes, we can destroy energy. Tulanga? Can we destroy energy? He said you can destroy energy. Tulanga, where did the energy come from? Carrying the bucket. Did you create the energy? And can you destroy that energy that you used to carry the bucket from point A to point B, the balloon? What do you think? Your opinion from the activities that you did. Anga? Okay, we'll come back to you while you're still thinking. Merci. Three questions. What do you think of the three questions and the activities? The energy that you use to carry. Others listening to Messi?
To understand the energy came from whatever sources that contain energy.
And did we create the energy when we were carrying the bucket from one point to the other and back again?
Yes.
Do you think we can destroy it? Did we destroy the energy when we were carrying the bucket from one point to the other? No. Yes. Karaut.
From our group's own thinking, we created energy by lifting the bucket up. When we put it down, we destroyed energy.
Destroyed the energy. Good answers. Energy, we have energy, we have stored energy, potential energy, which we get from the food we eat. Now, when we carried the bucket, the activity that we did, first activity, when we carried the bucket from one point to the other point, that energy, we used it as a moving energy, which is kinetic energy. And back again. We used that energy. We did not destroy the energy. Did you destroy the energy? The energy was what? Transformed or changed from one form to the other. This morning when you woke up, you ate. And you used that food went into your stomach, digested in your belly, and gave you strength to walk to school, gave you strength to think, and you use up this energy which is provided by the food. The same as the other three activities that you have gone through. Receiving teachers, you may go through with the students after the lesson in your own time. Let's move to activity B. In activity B, you will illustrate the change of energy from one form to another. We demonstrated, so now you will draw it as a diagram. You will illustrate that. Example is given for you. Receiving students, that is the example you can see. Here are the three exercises which you will try out by writing down the transformation of energy in a diagram form as shown in the example. Who's done? Are we done? Oh, good, good, I see. Some people are very fast workers, which is good. And discussing also. Example. Oh, this group is fast. I see all members have filled the worksheet. Good. Well done. Very cooperative group. We'll have you to answer one of those. Anyone? Okay, good. Thanks. Right. Some explain. Okay, good. This one? Hey, people blame you to stop zero. Boys are doing well into sick. Right. I see most groups have completed the 3 activity on the last exercise. We'll have one from Quarry's group. They can choose to tell us the transformation of energy from one form to another. Mother digging in the garden, heat and light from the fire, or music from the radio. Quarry, one of your members, listen to our friend.
Our first answer is kinetic energy, light energy, chemical and sound energy.
Mother digging. Chemical energy. When she eats food, it is chemical energy. Is it? And it changes and is used in kinetic and sound energy. Second one, let's have Riku's group. They have done the first one, so you try the second one.
Heat energy, potential, and gravitational energy.
Heat, energy, potential, and
Gravitation. Gravitational.
okay. The last one. Last one, Shane, your group. Others listening?
Potential energy and sound energy.
Thank you for the answer. Okay. We have looked at those 3. All types of energy were involved in those 3 activities. Before we end, our summary points for you to copy down. Why do we save energy? Why conserve energy? Okay. Those are our summary points. Number 1. Our next summary point, 2 points. You can have your friend read and someone write it down. So help your friend to read and your friend writes it down. That would make it easy. before we finish, you have a homework to do. Your homework: identify and list examples of conversion of energy. Conversion of energy, changing forms of energy. List some examples of other forms of energy that are changing. Receiving students and teachers, our keyword for today: conservation. In our next lesson, teachers, these are the materials that you will have to prepare for your class. And our next lesson topic is sources of energy. The energy that is used, that we use, where do they come from? What is the source of energy? These are the materials that you will need for your next lesson. I thank you, HC, receiving teachers and students.